Hi everyone, today we're going to be starting the final code for the ROV. We're going to create the code for the ROV in 3 stages. Stage 1, we're going to focus on just the servos and get them up and running. To use the servos, we're going to use the right joystick and we're going to use the y-axis direction, so the up-down direction, to make the robot go. Either vertically through the pool or down to the bottom of the pool. Now you have your choice. If you want to have like an airplane control where you pull back, you pull down, and then the robot goes up, that's fine. If you want us that when you pull down, the robot goes down, that's fine too. It's your choice, but you got to be really clear on what you're coding. I'm going to code the way where if you push up, the robot goes up, and if you pull down, the robot goes down. But the other way is totally fine. I'll show you how to do both. All right, let's do this thing. So first things first, we're going to, let's just go over the rationale for the code. So starting in the upper left-hand corner here, we're going to read the y-axis of that right joystick and store that value in the rjoy variable. So we have to create this variable when we're in there. We're going to map, because remember the joystick gives us values anywhere from 0 to 1023. We're going to need to map those values to something that the servo motors can use, which is an angle between 0 and 180. And we're going to store that new mapped value in 3 variables: the L servo angle variable, the R servo angle, and the F servo angle. Now you might be wondering why I use those letters. I'm calling my servos left, right, and front. If you've called yours something different, you use the names that make sense for your servos. So my 3 servos are called L servo, R servo, and F servo. So my angle variables are going to be called that angle, angle, angle. So use your names, don't use my names. Code for your robot, not mine. Okay, then we need to run a quick check. We want to make sure that we don't ever send the servo motor something outside its range. So 0 to 180 is its range. We want to make sure that if it's over 180, so we're going to ask this question here, if the servo angle is greater than 180, if that's true, we're going to set that angle back to 180, and then we're going to send it to the servo motor. And then we're going to do that same check for all 3, for the L, the R, and the F servo angle, to make sure they're not over 180. If they're not over 180, we're going to move down here and we're going to say, okay, if the servo angle is less than 0, so it's a negative number, we need to set the servo angle back to 0 and before we send it to the actual motor. All right, now if we come through here and we say we get our servo angle, and we get here and it's not greater than 180, and it's not less than 0, so it's somewhere between there, totally fine. That will go to the false one, and we'll just immediately send it to the motor without having to change it back to something. So that's how this works. And then once we get here and we send them to the motor, the whole loop starts over again, and we read the axis again, and we map it, and then we send it back through all of this. So this is constantly looping in the program hundreds of times a second. All right, now that we have kind of an idea of what's happening, let's go code it. All of this flowchart ends up being like 40 or 50 lines of code. So we've got some work to do. Let's get to it. I'm going to open the Arduino web editor, and I'm going to change the name of this sketch to ROV code. Actually, I'm going to call it final ROV code, in case I have something else that says something like that. And then I'm going to call mine video version, so I know this is the one I used for creating the video. And I'm just going to click OK. You don't need video version on yours. All right, it's renamed my file up here. I'm actually going to move this because I want to keep my stuff really well organized. I'm going to move the sketch to, and now I'm going to have an ROV folder, move. You may not have enough sketches to need to organize them, but I have hundreds of sketches, so I'm trying to keep mine really well organized. All right, up until now, we really haven't used this top header part. So what this is this slash asterisk and then asterisk slash defines a multi-level comment. So anything between those 2 sets of symbols is a comment that the computer just ignores, but it's there for other humans. So I'm going to do a quick one in here that explains what the program does. So this sketch controls the E and R to ROV. Another thing that should be in this header space is if you've got anything plugged into the Arduino, you want to tell it where it's plugged in at. So I'm going to call this the pinout. So the pinout describes where everything is plugged in at. I'm going to hit tab over, And I'm going to do my first thing, which is my rjoy y. rjoy y. So that R stands for right, the joy stands for joystick, and the Y stands for that Y direction of the joystick. And I have mine, I'm going to hit a tab a couple times over, and I'm going to have mine in A3. Don't just put what I have here, make sure you're seeing which one yours is plugged in. So for me, I do left before right, and I go X before Y. So my left joystick X is an A0, my left joystick Y is an A1, my right joystick X is an A2, my right joystick's Y is an A3. So that's the way I do it. The more organized you are, the easier life will be. I follow that pattern always. Left before right and X before Y. I'm not going to put the other ones in, although you can. We'll put them in future videos when we use them. Today we're just using the rjoy y. We're also using 3 servo motors. So I'm going to say, okay, I'm going to call mine L servo. Whoops, L servo. And I'm going to tab over to there, and I'm going to say, hey, that one is in, for me it's in 5. And then I'm going to copy and paste this line a couple times here, and I'm going to change the L to an R and the L to an F. So I have L, R, and F, left, right, and front. And the other ones are in 9 and 11. Awesome. So that's our header built. As we do more stuff and we add the thrusters and all the other things, we're going to put them in this pinout list. So if you want to take a time now to add a bunch more stuff, feel free. Just make sure that it's consistent with the way you've wired it, not what I'm putting on my screen. Don't just copy mine. Your code will not work on your robot if you're plugged in differently than I am. All right. Or you can also rewire your robot to be wired the same as mine. So in the void setup, I'm going to actually open a serial communication because we're going to need to check a bunch of stuff. So serial.begin. This command allows us to, misspelled serial. I knew that because it didn't turn orange. And I'm going to put 9600 in here. That sets the speed of the connection. And I'm going to do // and then put a real comment in. So this opens a serial connection with my laptop or my computer. Without this line, I can't do a serial print to check to see what's going on in my program. All right, for now, that's all I really need in my void setup. So I'm going to come into the void loop, and I'm going to go back to my ROV notebook and take a look. And the first thing we're supposed to do is read the y-axis and store the value in rjoy y. All right, awesome. So first thing I want to do is think, I've got 2 ways to read. I've got digital read and analog read. I'm going to remind myself that digital is for devices that only go on or off, like a switch or a button, whereas analog can have a bunch of different values, anywhere from 0 to 1023. So we use analog reads when we have a device that can have a bunch of different values. So that's what we're going to use because our joystick obviously isn't all on or all off. There's some intermediate values. So I'm going to go analog read. And I want to put here where the joystick is plugged in at. So that's going to be A3. But I don't like using A3 in the code like this because if I need to change the wiring of my Arduino, I don't want it to search my code trying to find all of the A3s I want to do. So what I'm going to actually do is come up here and I'm going to create a variable. So int to say an integer variable. And I'm going to say, I'm going to call this one the rjoy y pin. So notice how I've capitalized and everything. I'm trying to be consistent with this name, and I just put pin on the end of it. I'm going to do equals A3, semicolon. And now instead of A3 right here, I can just double click the rjoy y pin, Control C, double click the A3, Control V. And I just pasted it in there. That way later, if I want to change this A3 to A4 or A2 or whatever I need to change it to, I change it here once, and then the Arduino automatically goes through the code and finds all the joy pins and changes them all for me. All right, I need a semicolon here. Now this would work great. If I load this on the computer, the Arduino would read this value, but then it would instantly forget it because I didn't tell it to put it somewhere. So to tell it to store the value somewhere, so it's going to go read something like 420 from the joystick, and it's going to be like, oh, forgot it already. So we got to tell it to put it somewhere. And the place we're going to put it is in a variable, and we're going to call that variable rjoy. But I'm trying to use a variable, I haven't created one yet. So I'm gonna copy and paste my name here, Control C. So I double clicked on the rjoy, Control C. Come up here, do another integer. I'm gonna put a space in between them. And then Control V, rjoy is equal to, and what should my starting value of the rjoy be? I don't know, 0. I don't have to put a starting value if I don't want to. I like to always put them if I can. In this case, it's not going to matter what I set it to start with, because the very first thing in my code, it's going to read the pin, it's going to read the joystick's Y pin, and put a new number in there right away. All right. So let's put a comment here. We're required to have comments on all lines of our code, except for making variables. So all these other lines of code we'll put comments on. So this reads the rjoy pin and saves the value in rjoy variable. Maybe do in the. All right, so far so good. Hopefully that's going well. I'm actually gonna, that doesn't matter. All right, let's check back with our notebook and see where we are. We just read the y-axis of the joystick and we stored it in rjoy. First box done. Look at this. We're making so much good progress. We're already through the first box, or the first bubble. Now it says we need to map the rjoy from the starting values of 0 to 1023 to the servo values of 0 to 180, and then store that in something called L servo angle, R servo angle, it's hard for me to say, F servo angle. All right. So down here, I'm going to open up, I'm going to do a couple enters just to push this ending bracket. Remember, all my code needs to be between this opening bracket for void loop and this ending bracket for void loop. So I'm going to come down here. I'm going to leave a space just to organize my stuff. Ooh, actually, let's just see if this is working. What are we doing? So let's do a serial print here. Serial.print. And we're going to print put quotation marks, rjoy. We're going to literally print those words on the screen, semicolon, semicolon. And then normally we would come down here and we would do this, serial.print, and we would actually print the value stored in the variable. So I'm going to copy the variable name and paste it here. You can retype the variable name, but I find when I do that, I'm making lots of mistakes with typing. It's just faster to copy and paste. All right, and so it's going to print this one, and then next to it's going to print this one, and then we wanted to go to a new line and repeat that every time. So we're going to do ln here and do a new line. This is one way to format it. The other way is to put things that are on the same line on the same line. I can actually put this here after this semicolon. The semicolon is what tells the Arduino that that line of code is over, and not the enter. So I can put it here and here, so now I can see that it's going to do this one, and then next to it's going to do this one, and there's going to be an ln here. All right. So I'm going to format mine this way, and I'm going to put a little thing here, and it says checks to see if analog read worked. So it's going to print this on the screen so we can see if it works. Let's go ahead and upload it to our Arduino and see what we're doing. To check the values, I'm going to click on the monitor here. And as soon as everything's downloaded and ready to go, it will pop up values. Hopefully it will say rjoy and then a number next to it. Now mine's a little chaotic. I don't know what's wrong with my serial monitor, but it just looks weird. Yours should be hopefully really smooth. If not, let me know. I won't be able to solve it for you, but we can at least know. So you can see it's changed to 1023 here and to 0. Okay, so it looks great. So that's my right joystick in the up-down direction is changing just like it's supposed to. I can get all these intermediate values. Perfect. All right. So that's, well, before we move on, we know this one's working. So what I'm going to do is click on the number 21 here. That'll highlight the entire row. And then I'm going to do Control/, and that's going to add those 2 slashes at the beginning, and it will comment out that. So next time we load our code, it won't do this serial print. We know it's working. We don't need to mess up our serial monitor with all this extra data now that we know it's working. All right, in the next one, we'll continue with that second block. Good luck. Hang in there.